Discussing two events this week. One is Nvidia earnings, the other is Rivian earnings. Nvidia has proven again how important the company is in the pursuit of this new wave of AI, which generally is called generative AI. The idea of Nvidia being so instrumental has been for a while now the combination of hardware and software and the necessity to use Nvidia technology to train and to do inference. And the earnings call confirms that in several ways. There is more adoption of more advanced technology with higher margin, more exclusivity. When you have an earnings call where people talk about allocation of products, that usually is a very good sign for the company. There is caution here. We had that same situation a while ago when Tesla hit their peak allocation of cars, whether this company gets more or that, or which customers get first access and things along those lines. And that can also backfire. But I think in the case of Nvidia, the thesis of Jensen Huang is that the data center is the unit of compute, and the data center is comprised of hardware interconnect and a software layer that helps people program. I also want to mention one more thing here, which is something that I've gathered from my sabbatical at Stanford, and that is that in one of the lectures, Professor Lady said that the problem with accelerators in this modern area of AI is that they are usually lagging behind with compilers and other software components that are important for hardware, because when you train models, you are exposed to a lot of software efficiency, a lot of libraries and things along those lines that are necessary to make the lives of whoever's using that hardware easier, and sometimes even enable the use of hardware. And this is the fine line that NVIDIA is able to walk. CUDA is a key component of that, but it's not just CUDA. It's many components that I'm not super familiar with, but it just is coming across in several ways. One is of course the high demand, the other is the high margin, and the third is also the happiness by which customers are deploying NVIDIA. Tesla, whether it's Microsoft, whether it's Amazon, they're not in the business of helping Jensen Huang become a $2 trillion company. Clearly, there's a need and there is a solution, and NVIDIA fills that. So this would be the first talk. The second situation I want to talk about is Rivian earnings, and I think in a nutshell, Rivian earnings can be summarized as the market has spoken. I think the idea of Rivian being an independent company, I think, needs to fade. Rivian is at a point now where they need to find a partner. The company is just not viable in the current setup, and the reason is that they're not competitive. They're not competitive relative to Tesla, and they're also not competitive relative to other cars, but in particular Tesla. So this is not even wrong podcast. It's February 24th, 2024. This is Crimdalco. For the year we are up, for the day we are up 2.2%. The market's up 2.4%. For the year we are down 13.7%. The market is up 6.7%. We're underperforming by 20.4%. The two events I want to talk about, one is NVIDIA earnings. NVIDIA has shown again that they are indispensable in this new area of AI. Generative AI lives and breathes with NVIDIA. I think I've spoken already in a prelude about some of the reasons why that's the case, and I want to discuss really three things here, which I think are crucial. One is, why are people consistently buying more and more high-end NVIDIA products? Second, how is NVIDIA able to deliver that? And third, a little bit also, what are the risks in terms of, let's say, where could we see a problem arising in this context? So let's start with number one. Why is why are Nvidia products in such high demand? Why aren't people going with other vendors, Intel, AMD? And the answer is the data center is the unit of compute. Accelerated compute and matrix multiplications are the core of pretty much anything that has to do with either AI training or AI inference. In particular, transformer technology requires massive amounts of matrix multiplications and also massive amounts of high bandwidth memory, which is necessary to do to the matrix multiplication. In other words, you can have a GPU cluster, but if you don't allocate the data properly, if you don't allocate the data in an efficient way, your GPUs are idle, and then you lose performance, you lose money. You buy a big truck that can load a lot of stuff, and if you don't load the stuff properly, most of your trailers are empty. Or you have a train that can, transport stuff in parallel, but you don't have the right allocation of goods and services that you're loading the train with, and next thing you know, you're half empty. It's something along those lines. It's not the actual compute. It's the memory. It's the memory wall. It's the wall clock time. Things like that matter. And NVIDIA is solving that problem. In a nutshell, NVIDIA is not solving a compute problem. NVIDIA is solving I believe it's called wall clock time. So it's the actual time that it takes to execute a certain task. Let's say if you want to train a transformer, like a masked autoencoder, for example, you need a certain amount of time to do that, and NVIDIA is giving you the best bang for the buck. So you might pay more upfront for a solution, but overall, you will get more for your money if you use NVIDIA. That's where NVIDIA stands today. People are trying to compete with NVIDIA. There's a little bit of a chicken and egg problem here, which is that you can put hardware in place. That's the easiest part. Not that that's easy. Kudos to all the engineers that are working hard to solve those problems, but you can do it. There's accelerators, whether it's Amazon, Microsoft, or Facebook, whether it's Tesla, and then there's all the companies like AMD and Intel and Graphcore, the startups of this world that are trying to do the same thing like NVIDIA. Where they fail or where the problems start is with the software side of things. So let's say you have convolutional neural nets, which is a certain way of architecting data that comes in, and let's call them state space models. State space models, those are models that bring data continuously into the training set, and then what happens is you have the state T, and then state T plus 1 is going to be the new data plus the state T, and then T plus 1 is the new state T plus 1, and then T plus 2 is the new state T plus 1 plus the new data, and so on and so forth. These are state space models. Two of the most used names or architectures in that context are recurrent neural nets and convolutional neural nets. Now, the masked autoencoders, which are part of this new generation of transformers that are dominating generative AI these days, they work a little bit differently, which is think about it, instead of constantly bringing in data and adjusting the state with the new data, you are in one shot training a massive amount of relationships between data. That's what self-attention it does. You're looking at positioning of words and the relationship of words with each other relative to their position. So if I have a sentence, I am taking a hike in Lake Tahoe, then Tahoe and IM have a certain relationship, Hike has a certain relationship, and from there, the models are able to infer semantic meaning, and that's what makes them so powerful in the semantic context. We're looking at a generation now of models that are going multimodal. So we're going to have models that take into account not just text, but also audio and video and other sensor information. And that's where things like long context window come into play. That's where things like flash attention come into play, which is a way to make mass-well encoders more efficient. There's a lot of work being done in academia. There's a lot of work being done within Nvidia, within other companies, particularly Facebook and Google, that try to make these training instances more efficient. The risk for Nvidia, and I want to talk about the risks a little bit later. Why don't I go to point two now, which is, okay, how is NVIDIA even able to do this? Like, let's say we have a theoretical thesis here, which is we have a company that builds the platform, offers you a software layer that helps you program these new models. Actually, I was jumping a little bit ahead. What I was trying to say with the convolutional neural nets and the RNNs, the recurrent neural networks, is that we have this change in architecture, and we're going to have changes in architecture going forward, continuously changes in architecture. And that's why we need a flexible platform that works a little bit like, and I'm paraphrasing Professor Horowitz, Stanford engineering professor, that hardware design is almost becoming like a sort of the app store where software layers are being adjusted. So you have a hardware which is flexible enough to be adjustable through software, and the software is done in a sort of let's say tile way, where building block way, where you have maybe some libraries which are fundamental, and then other libraries which are adjustable, and then maybe certain just for the sake of the argument, you have a matrix multiplication, which is software defined, and you can adjust that matrix multiplication based on, let's say, the high bandwidth memory that you need, and all of these things are software defined. So you have software defined hardware. That's kind of where NVIDIA is. If you want, NVIDIA is a software defined hardware company, and of course that's not terribly new. Intel's x86 was a massive success because Intel was, in a nutshell, a software-defined hardware company. It's just that NVIDIA has taken this to the next level, and it has built an innovation stack around matrix multiplication and models that utilize matrix multiplication in various ways. This is, I would say, in a nutshell, what makes NVIDIA so powerful. Paraphrase Jensen from one of the GTCs maybe almost 10 years ago when he said, the beauty of NVIDIA is we have a day job, which is gaming and graphics, and that day job translates beautifully into AI, and that's why we're a leader in AI. So this is, I think, in a nutshell, why NVIDIA is so powerful. And the question now, how are they able to do it? And I think people don't spend enough time thinking about the hardware side of things, the engineering side of things, the iterative ability of NVIDIA to continuously come up with new things. I think NVIDIA has taken, or Jensen and his people have taken a lot of notes from companies like Tesla. It's almost like NVIDIA has become the incarnation of Elon Musk in the software-defined hardware space. And while Musk is building software-defined hardware in the markets of transportation and space, in neuroscience, or links, through Neuralink and things like that, Jensen's focusing on the compute stack. But they're both he's taking a note from that playbook, if you will, and that's why he's so successful. But what I want to say in the second point is, I think we don't spend enough time talking about the engineering aspect. Now you can
obviously make the argument NVIDIA has the best engineers, NVIDIA has this, NVIDIA has that. But that's a vacuous argument, because you have the best engineers because you are the most valuable company, because your stock is going up. Everybody wants to work for you. So that doesn't explain why you're so good at what you're doing. What explains what you're so good at what you're doing is something, an independent variable. And the independent variable here is Jensen Huang. What he's able to do is very similar to Tesla. He's able to grow by using existing assets, making money, and also doing R&D research, iterating around solutions for problems that will come in a couple of years. CUDA is a good example for that. When CUDA was launched as a project, it cost a lot of money back then. For whatever Nvidia was, it was expensive to build CUDA. Today, CUDA is the main driving force of the success of Nvidia. Today's CUDA is, according to Jensen, Omniverse. Omniverse is another software-defined platform that helps in graphics and image and video editing and video generation and video manipulation, and all of these things which are pivotal for example, for simulation. And if you want to take this to the next level, you can say the future of robotics is going to be in simulation. So I think I can see those Lego blocks being all put together. And the strength of NVIDIA is to have this ability to build a business and then use part of that business, which is generating cash flows, to do R&D for the next level of business. This is very similar to Tesla. Again, this is part of the playbook of Elon Musk. We have Model 3 as a platform that can be then transferred into Model Y. We have Cybertruck as a platform that will be transferred into the next gen vehicle. Those are things that are expensive to do. They're not cheap. For example, in Tesla's case, we have to experiment with single casting. We have to experiment with 48 volt. We have to experiment with design. How does edgy Cybertruck design come across to the public, and then we'll use the same design for the next gen vehicle. So there's a lot of R&D that is being paid by the customer. Of course, Tesla has the other big R&D project, which is the self-driving car, which is also being driven, or the project itself is driven, pun intended here, by the customers. So those are, in my opinion, that's the main advantage of NVIDIA. So it's not the fact that they have the best engineers, the fact that they have the best service, whatever. These things are all effects of the magnet that Jensen has built, and that magnet is driven by his ability to take those types of risks, which are literally calculated risks. So they are risks, of course, but they're not. This is not a company that is tinkering and trying and breaking and trying to fail and do, a la Google X or Amazon. This is a company which has a very almost linear way of progress, but it's a very fast and exponential way of progress, because you have the compound effect of learning and doing R&D on top of a business which is generating cash flow. Now, the last thing I want to say about NVIDIA is now the risk, and I think the main risk for NVIDIA is ARM. And ARM is a company that has been able to penetrate markets from the low end, so they're very Clayton Christensen-like in that sense, and they're still doing it. They're now progressing into the edge. Smartphones, they're being used for inference in the edge, in particular smartphones, but you could imagine Internet of Things in the future being using Gen AI for things like sensors, for things like little compute sensors in the electric grid, and God knows what. So we could use ARM in space travel. We could use ARM in a lot of things where AI is being used as inference. So anything which has low power, low battery consumption type characteristics, ARM is a winner. That's why NVIDIA wanted to buy them. They couldn't buy them because of China. China is a big part of the business now. So there's a connection there. We believe that is the biggest risk. It's also a very good case for ARM as an investment, and we're contemplating that. The downside of ARM is the ownership. It's not something that we like. That's for another podcast. So ownership is a problem. Management is a problem. They seem to be doing a very good job in exploiting trends. However, the trustworthiness of management is a bit of a question mark on our side. Lastly, now talking about Rivian, the earnings call can be summarized as a statement by Wall Street: enough is enough. We don't want this company to be public standalone anymore.
What that means for the company, it means a couple of things. It means the necessity to find ways to finance growth, whether it's through an equity issuance, whether it's through partnerships. Maybe Amazon can commit to another 500,000 cars, or something like a almost a barter, where product for equity, or something like that. It's not clear, but clearly, as a standalone company where they raise money through equity and bonds, invest in products and services and sell them, that is not on the table anymore. Wall Street has said no. The stock trades about 1.5 times cash. So this is certainly a very cheap stock at this point. And the reason the company is so cheap is because the street doesn't believe that the money invested is invested well, that the return on investment is negative, that the company would be better off returning the cash and just folding. Now, we don't have much of an opinion about whether this company should fold or not and things like that. What's important for us, we are heavily invested in the electric car space, and for better or for worse, the consolidation now is in full swing. Which means a lot of startups and smaller companies have raised a lot of money in the last couple of years, and they're all being pushed out of the market. We're going to have a situation where in the end, probably only two big players will survive, and one is Tesla and one is BYD. There's potentially maybe another company, something, but it's hard to see that happen, because there just isn't anybody out there right now that has the know-how, the potential, the will, the intellectual capacity, the engineering talent, the risk capacity, and what all of these things are not present in, whether it's Volkswagen, whether it's GM, whether it's Li Auto, or NIO, or you name it. Nobody has it. BYD has it, and Tesla has it. So we shouldn't reason by analogy, but we could still say, well, we could have a Samsung slash Apple situation here. Maybe we should incorporate Kia here. The Koreans are serious contenders, so there could be a trifecta maybe. So one large supplier from China, one large supplier from Korea, and one large global supplier in the name of Tesla. Whether that happens or whether we only have two is probably, well, the question for us is, okay, what does this mean? I just want to be clear. I want to talk about two things here. One is the Rivian call, which in my opinion is the beginning of the end of pretty much anybody out there who is competing in electric. What we're predicting here is that nobody will have an electric car manufacturing capacity left going forward, other than Tesla and BYD. There will be a lot of plug-in hybrids and those type of things, but those things only are surviving because of ill-advised subsidies, and to some extent some inertia, customer inertia. So you're a BMW driver, you want to feel good about yourself, so you buy a plug-in hybrid, things like that. But those things will go away. Those are not sustainable. BMW has launched a new fully electric car, which is almost double the price of Tesla. That's just not sustainable. And we have, in the cell phone space, there are high-end phones. I believe they still exist. Very fancy, nice high-end phones with diamonds and things like that. I mean, there are, but those are low volume, irrelevant type offerings. So we're not counting them. Well, the global, if we take take 100 million cars a year sold globally, including trucks. We expect the bulk of those cars to be sold through Tesla and BYD in the maybe 5 to 7 year time frame. And this week's Rivian call was an important pivot, one of those points, waypoints that point in that direction. I guess that's what we're trying to say here. For shareholders of Nvidia, for people who follow the space, of course, there's many vectors of attack here. Oh, you don't know what you're talking about. Competition will come. It's a commoditized market. Blah, blah, blah. Yes, and yes, but. In the end, low cost is the only vector that matters. Maybe that's not the right way to say it. It's low cost and high value. So the highest value, as defined as how much do I get for a dollar? That's what's going to matter. And Tesla is just way ahead of everybody else. It might not show in the monthly payment that you have to make now for the car, and that's because there's also a lot of shenanigans going on. BMW, for example, is subsidizing, Mercedes subsidizing their monthly, but they're not really subsidizing. What they're doing is they would say things like it costs you $320 a month, but then the fine print says you have to put down $20,000, which is very unusual for a lease. You usually put down $5,000. So there's things like that going on. In the end, most cars are at least double the price, if not more. And the reason Rivian is not able to survive is very simple. Their cars are way too expensive to produce. They don't know how to make them cheaper, and that's why they are not viable as a company. To summarize, two big events this week. One, Nvidia's earnings call, which cements the leading position of Nvidia as a software-defined hardware company, and Rivian basically being raised as a public company. And I think it's not just Nvidia. The reason we believe this is important, it is the beginning of the end of this proliferation of electric car companies. We're going to see a consolidation and eventually reduction into two large global suppliers of electric cars, or of cars in general, and those will be Tesla and BYD. Thank you.